lakes and data warehouses. We have been Pragmatic Works partners for a little over a year now, and have enjoyed the partnership. Specifically, the tools that one tool in particular that we use a lot of is the Task Factory tool that is a component to Boost SSIS, and we highly recommend it. So thanks for the opportunity. So today we wanted to talk about data lakes and data warehouses. It helps to understand who we are as a company, to know the perspective that we bring specifically to the data lake world. My name is Nathan McMurtry. I'm the CEO here at Zerva. Zerva provides a fully managed data warehouse. We call it DWAS, a data warehouse as a service. We provide that through Azure, and our big company goal is to build 1,000 data warehouses. And so it looks like we're cut from the same cloth that a lot of you are, on looking from the poll where 85% of you are currently building or have built a data warehouse. It's really good, useful information to know who we're talking to today. Our company spent a lot of time over the last 4 years building data warehouses and maintaining them for clients. And as we've built those data warehouses, we've heard a lot about data lakes, and we've learned a lot about data lakes, and have developed a lot of opinions about how data lakes can be incorporated. And so that's what we're hoping to share today. Just kind of as an agenda set, I've got a handful of slides here, and then we've got a really good demo to take you through. So there'll be just a few slides. So to set the table for data lakes, this was, if you're familiar with the GARTNER hype cycle that they do, the data lakes have entered what they call the trough of disillusionment. This was published July 2017, so it's a few months old. This hype cycle, the important parts to know is that the very top of the hype cycle is usually where the wrong people are using the wrong tool for the wrong job. Everybody's trying to make a tool fit something that it really wasn't built for or meant for, and that's really where data lakes have been. I think if you've been in the BI industry and listening, you've heard a lot of talk and a lot of possibilities for the data lake. As we enter in this trough of disillusionment, the important part is to know that very soon you expect for people to really start picking it up for the right reasons and the right tool and the right job for the right person. And that's where we're headed. And we've spent a lot of time as a company trying to get to that right product fit. So the big changes happening in BI, the size of data that has been exploding, the database structures, we've seen a lot of unstructured data scenarios coming through, and the structured databases don't necessarily have the best answer for those. One of the things that we looked at when we were talking about data warehouses is that it felt like IT departments were making a lot of judgment calls on what business data was valuable, and then kind of locking away the rest, saying, this isn't blessed data, let's not let the business use it, and sometimes locking it away, and sometimes at worst actually throwing it away. And so that's one of the changes we saw happening. We've seen a lot of changes recently also with the use cases for real-time data. Many people have very good business cases for real-time data, where in the past it seems like a lot of people who would come on maybe didn't have a really good use case for why they needed real-time data scenarios. And then the advent of these new Viz tools that bring a lot of data science into the Viz tool and the connectors they come with, it felt like a lot of people were trying to circumvent the BI team. And so the end result where we kind of found ourselves is that the BI team was losing control of a lot of their users, that the data warehouse needed to evolve. And we've looked as a company at the data lake to really solve some of these things. It's not the silver bullet for all of these things, but it certainly helped in supporting these things. So this is, according to Zerva, this is kind of how we see the Azure BI platform. The idea going left to right on this slide is that we have our data sources, and we can pull from on-premise, cloud, or any of the IoT the things that beep as data sources, and we can extract those into Azure. Once those are extracted, we see the data lake storage as being kind of the landing spot for the first part of building a BI solution in Azure. And that data lake storage can be, and this is an important part that we'll hit on in a little bit, but it can be an Azure Data Lake. You can build a data lake in Blob storage, and you can build a data lake in a SQL database. It just depends on what your specific use cases are. That data lake can then support the building of a data warehouse, whether you're building that data warehouse in Azure SQL Data Warehouse or whether you're building that data warehouse in just an Azure SQL database. Or that data lake can directly support any of the machine learning and analytics that Azure has to offer. From there, you've got your semantic layers, your front-end layers, where you're trying to make the data as good and as useful to the business through, and they can access that through Power BI or OLAP cubes or views. So this is just a high-level overview of the way we kind of see implementing Azure. So diving into data lake, what a data lake is or what it can be really varies depending on who your or what your specific business needs are. We see that data lakes are very good for near real-time scenarios, for the ingestion and supporting of near real-time scenarios. Data lakes often are untransformed data. They're still organization, which is important, but not nearly as transformed data as what you'd see in a data warehouse. This idea of a data swamp has kind of been thrown out, that people are kind of just dumping data in an area and calling it a data lake. It's definitely not that. Data lakes typically have no schema, and this is for better or for worse. The better is that you're not spending a lot of time needing to worry about schema for the storage of that data. The worst is that as you're trying to make business decisions off of the data, you need to apply that schema on write, and we'll show some of that. And that's the next point, is that the data requirements are usually not defined until the data is actually queried from a data lake. Data lakes, one of the things that you should have in a data lake is a full copy in one location. There is value of just being able to centralize your business data from all of the different data sources that exist, and having it organized in one area. There is great value for a business. And then the last piece is the data lakes, because it's on the Azure Data Lake, because it's on the HDFS tool set, you can store the structured, semi-structured, unstructured data sets, so you don't have to worry about some of the capabilities of a relational database. So that's what it is, and here's some of the purposes we've seen for a data lake. The central repository, being able to have all of your business data in one place. One of the great benefits of a data lake is that it removes the burden from the source system. So as business users need to go back to the data sources, whether that be accounting data or whether it be marketing or operations, web logs, you're trying to remove the burden from that source system. And so there's a great need for centralizing that data and removing it off of your source system. We've seen data lakes be very successful in supporting APIs and business apps. In the past, as we looked at data warehouses, the data warehouses weren't very good at supporting business apps, and data lakes, in the way that they're organized, really meet that need better than what we've seen data warehouses being able to meet that need. Supporting data science and machine learning, this is definitely one of the bigger ones, that this idea of data science in our world, going back 10 years, data science felt really out of reach. You needed certain degrees and you needed certain tools that weren't very easy to deal with. Azure specifically has really nailed this in making it accessible to train a model and deploy a model, and data lakes are really the place to support data science. The other purpose of a data lake we've found is that it helps with data auditing. One of the mistakes I felt we made in our data warehouses was locking away the unaudited data, the raw data from systems. whenever you were dealing with accounting and finance people specifically, they always wanted to take the data that was coming out of the data warehouse and audit it back to the source data. And if the data is being stored in a data lake that is untransformed and raw, it is a very good place for users to be able to come in, and at least you can hand them and show them the raw data without going back to that source system. Now, on the data lake, this is one of the most important things that we've noticed as we've rolled out data lakes to our clients, is that it typically will support a limited number of highly technical users. It's got a steeper learning curve, and part of that comes with the language that users need to know. Part of it is because you're kind of combining file system and coding versus just kind of the relational, I just need to know SQL user. And so we've noticed that you'll probably have fewer people using data lakes, but they'll be a more technical user. The data lake is very good for answering big ticket questions. The questions that businesses usually take weeks to go in and answer. That's what the data lake is about, specifically with the data science and the machine learning piece. And so knowing that you're not answering all of the questions for the business through a data lake, but you're answering some very focused big ticket questions is important. So some of the common mistakes of a data lake, the number one is that people ignore organization. The organization of a data lake is extremely important. Just because we're saying we're putting all of our business data in one place doesn't mean we're going to leave that unorganized. The second mistake is that we see people ignoring security, mixing sensitive and non-sensitive data, and finding that the data lake actually can't service the needs of the business because you have to lock everybody out. It's this all or nothing mentality, where if you focused on the organization, Azure has a great security model where you can not mix those two groups. Ignoring execution costs. So in the SQL Server world, execution costs meant how long does something take and how hard is it to get it from its current state to its next state. With data lakes, especially with Azure Data Analytics, we're talking about financial costs as well. They introduced the idea, which is kind of new for most people, that each query is actually going to cost you money depending on how many resources you put into that. And so that's one that we'll talk about in a little bit, of how to manage that cost and how to do it. But it also leans more towards, you're trying to answer those big ticket questions. You're not trying to just let anybody query in the organization in this data lake. One of the other common mistakes is that we're seeing people somehow get away from actually involving the business with building the data lake. This fits the same ideas that a data warehouse has always tried to fit, which is involving the users early and often in the organization, so that you know that you're hitting the right people with the right solution. I noticed that we had a lot of people, 85% of the people on the call were very familiar with data warehousing. So I just quickly took all the sliding out of this slide and just kind of want to hit each point really quickly. So the purpose of a data warehouse, in contrast to a data lake, is really supposed to supply that single source of truth. This is the place where most of the business logic is going to be applied. Things like data governance are being applied to the data to make sure it's accurate. Relationships are created here. The real key is this idea of a conformed dimension, meaning that we've created that single source of truth. We only have one table that defines our customer, one table that defines our locations, one table that defines our stores. That single source of truth is what the data warehouse is all about. And so the cleaning and the transformations is here. We do the lowest grain of data in the data warehouse. It's very KPI focused. The important piece of a data warehouse, as in opposition of the data lake, is that this is supposed to support a large number of less technical users. If you're not getting an adoption with a data warehouse, it means you've probably put some barriers in front of people who are smart but less technical. And so that's where we found a lot of success with OLAP cubes and semantic layers, making things as easy for the business user as possible. A data warehouse will answer many questions quickly and usually focuses more on historical data. So this is just a quick comparison. I'm almost to the demo. So this is just to wrap up the data lake versus data warehouse conversation. Data lakes focusing on real-time centralization, being flexible, being transactional, predicting future, whereas data warehouses are focused on things like accuracy and easily accessible data and data that's actionable. We see these kind of in conjunction, and so you can see how bringing both of these together into your business solutions really is a great idea for supporting everybody in an organization. So data lake storage. So in Azure, you really have 3 different places to store data and call it a data lake. And we try not to be, snobs about what is a data lake and what isn't, because it varies organization by organization and business need by business need. But know that you have Azure Data Lake as your as a great option. This one is built on the Yarn technology. This is HDFS. The SQL that you need to know is a tool called USQL. It kind of feels like it's a combination of C# and SQL. We'll go through a little demo of what that language looks like. You can also access it with R and Python. Azure Blob storage can be a data lake for organizations. If you're just storing PDFs or WAV files, or if you don't have a need to actually query your data, Blob storage is a great, cheap way to store data all in one place. There are ways to query Azure Blob storage. We piloted a Apache Drill, if some of you are familiar with that. It's a great way to query directly out of Blob storage, but it is more difficult to do. And then lastly, an Azure SQL database can be a data lake if it accomplishes the purpose of a data lake. And so those are 3 ways that we've rolled out data lakes. So organizing a data lake, we found a really good video for those of you that were at SQL Pass 2017. This Oost Oldfield, he gave a great presentation called Deep Dive into Data Lakes. And he's been the one that a lot of people talked about. You need to organize a data lake, but we never saw anybody who had a really good plan for it. We saw this video and immediately kind of implemented it for ourselves. And it's been a really great starting place. And the essence of it is, and we'll show you the way it looks like in Azure Data Lake in a minute, but taking data that is raw and then kind of left to righting it, enriching that data, and then curating that data, and keeping that batch process separate from what you're doing in your lab or in your stream, and keeping those business uses different and separated in their file system has helped us to organize the data lake. So I have sitting next to me one of my lead architects. His name is also Nathan, to make things easier, and he's going to be taking us through the data lake storage and security elements in Azure.
Hey everyone. So as you saw before on that last slide from Pass with maybe the raw data and enriched data and curated data, we were able to architect it similarly here just in Azure Data Lake. And so yeah, I mean, it really does just feel like a file system. So we just created just folders with that for raw data, and even within raw data, just having subfolders to help separate where the data is coming from, whether it's internally or externally with other APIs, third parties, or maybe like open source data, like .gov or things like that, and then a specific place for the data that you would use more for real-time analytics and things like that, and then from there it could get specifically into data sources. So the raw data, I guess, section or portion is more focused on the source and the data source. And the external might have some other sources, Google reviews or call centers or whatever it may be. And and that can flow into enriched or curated, and this is more focused on its destination rather than by source. And so we just have an example here of just ending up in a data warehouse, but and same with curated. So enriched being maybe adding some more columns, or with for example, maybe like sentiment, things like that, to just enhance the data, and then curated just being ready to be pulled into other systems, other things that can visualize that data. There's also, you saw on the past slide, like a laboratory section. This is more for maybe data science people that can just kind of have their playground of trying to answer those big ticket questions. And so this is just an example of how you could organize a data lake, and Azure actually makes it really convenient to just control the permissions and access. And so for any folder, you can get to the access here and add owners and groups, and it works with Azure Directory, and you can add read or write or execute permissions and have it go to subfolders and all the children from there. So it makes it very easy to.
So let me hit on a couple of things on that. So the security is, like Nate said, it really is just read and write. They have execute there, but execute doesn't really mean anything. You can either give people access to read and access to write, and that's really your two biggest options. The security, though, is it is very good. The data is all secure. It's encrypted at rest, and it is encrypted in transit as well. Do you mind clicking on the button that shows the expiration? So for any of these, I think you have to go down to the file level.
Yeah.
So when you're actually on your file, you can click on it. So say you have data that is for some reason sensitive, and you only want to store it for a while, you can actually set the expiration as part of your security measures on when you want the file to be removed. So that's another level of security. And then Nate mentioned this all ties into Azure Active Directory, and there's also, you can enable a firewall, so your own firewalls can be put around this as well. One thing that we did notice is with Azure Active Directory, because you're setting the security at the folder level, if these files are large and these folders are large, which likely they are, the security kind of propagates down to the subfolders. And so if you have large data sets, know that the security may take a while to be applied to those subfolders. One other point, this isn't on security, but something we've been learning a little bit more about is the way the files are distributed in Azure Data Lake. If you have 100 gigabyte JSON file and you think, man, I'm just going to drop it here and it's going to get distributed across the different nodes, you're going to find that you're going to basically break your Azure Data Lake instance. The files like JSON and even some CSVs, if it can't be broken down to a lower level, it won't be distributed across, and so you won't get all of that distribution that Data Lake can provide without actually breaking those files down into smaller chunks. And if you do run into problems, there's some specific techniques to breaking larger files down. Parquet and ORC are two that are good about ways to store files specifically to optimize kind of the distributed architecture of Data Lake. Go ahead, sorry.
Yeah, I think that's actually it for this little small data lake storage part of the demo.
Okay, so the next section, and we're going to come back to demoing, so that's just the storage and security. As soon as you start talking about how to analyze the data that you've stored in Azure Data Lake, you really have three good options. There's numerous other options, but these were the three that we like the best, well, that we've found the most success with. The first one is Data Lake Analytics. Data Lake Analytics is the kind of the combination of a lot of different things that Microsoft brought together, and the big things are it's an evolutionary language that it kind of got its inspiration from MapReduce. You can tell that they've used a lot of MapReduce elements in creating it, and it's organized on that yarn architecture. It's based on a Microsoft internal big language called Scope, and it's been pretty good for us to adopt. And so that data lake analytics has been good. The other two options that we've had success with is HD Insight. So this is Hive Interactive Query Language, LLAP, which stands for Live Long and Process. There was a blog that Microsoft put out in December that stated that this one was getting more and better performance than any of the others, including Spark. And so that's one that definitely is worth looking at as you look at analyzing your data lakes. Some of the and then Spark, of course, is a very popular, and seems like it's having great success in analyzing data lakes. The other things that you can do is you can connect all of the different things in Azure to your data lake. So things like streaming analytics, SQL Server integration services, Azure Data Factory, Azure Data Warehouse through Polybase, and the data catalog, and even Power BI all have connectors to Azure Data Lake now. So you have a lot of options in what you're going to do and in connecting to your data as it sits in a data lake. We're going to show now the data lake analytics part, which I think I'll let Nate kind of go over the USQL syntax language.
Yeah, so for this portion, I'll come back to that last slide as well. But we just wanted to show kind of how the data lake can be used, in tandem with the data warehouse as well, and really supplement it. So we're going to start just by showing USQL, that language for data lake analytics that Azure has provided, as well as just take a look at how the jobs work briefly, how you might use that with SSIS to bring in those curated results into an actual database, and then from there how you might be able to see that just visualized in Power BI. And so just really briefly with USQL, these are kind of just like the basic parts of what syntax looks like. So it's going to extract the data from your Azure Data Lake, and you can specify whether it's a single file like that, or even multiple files, but it all gets extracted to a row set, which is pretty much just like a result set. And that's actually the syntax there, just to be able to create that row set variable. It's a little different than what you might see in SQL with having to declare. You can also declare variables like that for other purposes in the script, but you can actually just do it on the fly here. And then one of the big things is to notice that it's the schema is created on a read, and it's not stored anywhere. So really, it's just used for the purpose of that script. So you can see that the data types are declared, as well as the column names, and the column names can be adjusted in the script as well, even throughout the process. And USQL provides this nice extractors function, so you can be able to extract from a lot of different kinds of data, tab separated, comma, text files, a lot of other extractors to be able to work with it. And then for all USQL scripts, the unique thing is it has to output to something, whether it's another flat file, or even into the data lake. I guess databases they have too. It's got to go somewhere. So we just want to show an example of that, and just with some anonymized data that we have here. So our use case was with a client that was a storage company, kind of like how you just kind of keep your storage in short to long term, like with U-Haul, or kind of renting a space there. And so they had things like surveys, or maybe notes about accounts, or even Google reviews of how they were doing. They wanted to have sentiment analysis done, just to see how positive or negative the free-form text was. And so this is just an example script that was used to be able to kind of pull in some of this information. And the cool thing about USQL is that you can extract from a single file and specify that, or it can even be, for example, like a directory of files. As long as they follow kind of a similar naming pattern, you can bring them in all at once into one row set. You could say, as long as they all follow the same pattern, it would just pick them all up as if it was one source. And so you can see here that the extractor, it's a text, but it's delimited differently than comma or tab here, but you can specify all of that. And USQL provides a very nice API to do text analytics. I mean, even using that API is just a simple call to a function. It's just a one-liner to be able to add sentiment and the confidence of how negative or how positive that is. And you can even bring in key phrases here. Again, it's a one-liner to be able to get that information, and it's just output to another text file. And it kind of just tags on the sentiment and confidence and key phrases. And so it's a very simple process, just using a script like this to be able to add in kind of that enriched data. And from there, from there, it would be ready to be able to pull into a SQL database or data warehouse. And so from here, you can see the count notes. This could be the file that has all the extra information in there, and we can just take a look at it just to see as well. So it came in as just as a flat file with columns, but it also has.
So the file already had all of the columns up till comments.
Up until comments, and so you can see that the API added sentiment as well as confidence and just key phrases over here on the right that's delimited. And so it's still pretty much the same file, and so that's why it would be a good place to still keep in your Azure Data Lake, but it's ready to be pulled into another system. And SSIS has, here's the sample package in SSIS that might pull in kind of that information that you can specify that directory, that curated directory, and for each of those files that has that sentiment analysis, you can see that they have connectors in SSIS for an Azure Data Lake source, and you can just specify all that and bring it right directly into a database table from there.
So in the data lake, you took a raw text file, you threw it out, ran it through the sentiment API, added some enrichment to it, and then from there you were able to connect through SSIS to load it into a data warehouse.
Yeah, exactly. And so it's very nice to have all those files, which can get large in size and quantity, and not actually have it in the database in its raw format, but then you can just bring in the pieces that you need to after it's been enriched.
Can you go through the actual job part of
Yes.
Azure Data Lake?
Yes. So with those scripts, if you actually create a job to run these scripts, you can see here very, very similar format with the extract. It's a similar script, and so I had to loop through at the top. So this job graph kind of shows all the files, and so it's not a ton. It's maybe 9 files, but you can specify how many resources you want to add to it. They're called analytic units and AUs here, and I can show that in a little bit. But this is kind of the execution plan that's going to take here. And so with specifying, so you write your script, and then you can specify here anywhere from 1 to 250 how much resources you want to throw at this particular job or query. And
so this is an important part because the cost can really add up if you you've ever run a $200 query, if you've never run a $200 query before, you might be surprised at what's happening here. The math is that it's taking the minutes, the duration the query takes to run, and it's multiplying that by the number of analytical units you have. So right now, Nate's got 5 analytical units, and then it does an average cost per minute. And that calculation gives you, so right now the estimated cost would be about 17 cents a minute for this to run. The short answer, if you're kind of nervous about how much a query is going to cost, is the lower the number of analytical units that you use, the cheaper the query will be. So you're going to wait longer for this query to run, but you're going to save more money. If you took that all the way up, if you were just running a test and you said, hey, let's do 50 analytical units, you're going to be spending $1. But if you did 250 units, you'll be spending $8 a minute for that query to run. So just be really aware that you probably want to, this is one of those things you want to start small and then scale up as needed.
Yeah, so I was able to run this job with just 5. I just wanted to kind of test out the distributed nature of it. And it actually shows kind of the path here, and actually has a playback. And so because there were, looks like 9 of these files, and since it was using 5 AUs, it actually kind of broke it up into 2 batches. They would do 5 at a time, and then the next 4 that falls into that batch. And once those 5 were finished, it went on to the next process. And so they actually have this handy playback feed. You kind of see the process of what it looked like as it was processing. So you can see, yeah, so this is the first 5, and they start going green. Okay, it's finished extracting them. And once those first 5 are done, it moves on to the next process, and the next ones that turn blue or with those next resources. So you can kind of see how it's going through all those files there until it outputs to a single file, and the process just continues. So it's all very specific to the use case of how much resources you need and throw at it, depending on how big the data is and how distributed it needs to be.
So there's a longer conversation here about partitioning strategy. It kind of plays into how many analytical units you're wanting to use at once as well. So the way you partition your data and store it is a really important part of using data lake so that you get optimal query results. The other one is there's a kind of a new part of a query called distribute by. The distribute by is you're telling Azure Data Lake how you want to query the data, and the queries really can follow one of 2 routes, either a round robin or a hash. The round robin is the default, and just know if you just kind of launched it like we're showing right here, I don't think you put any distribution by on any of your queries, did you?
No.
So by default, these queries that we've been demoing are using round robin. That's if there's no obvious way to join your data, this is the place to be. If you're kind of using a temp table format where you're just going to create a table and then throw it away, the round robin is appropriate. As soon as you want to as soon as you have a bigger file than like 2 gigabytes, then you'll want to start using a distributed column or a hash key. And what that is it works not unlike a primary key, where you're going to designate one column to be your distributed column, and that column is as you actually specify in your query to use a distribution by with a hash, it will return your data set quicker. So you're able to query much larger data sets with that. You're also able to do frequent, so if you have these frequent inserts and updates and deletes that you need to do on a table, that's where a hash key will really improve performance. The only downside to the hash key is the maintenance around it, that you can't actually change the hash key. If you want to edit it, you have to delete that column or sorry, that row. You have to delete the row and then reinsert the row with the new value. So just know as you start getting into this, the partition by and the distribution by, there's a strategy around both of those depending on what your use case is.
Yeah, so I've been able to show just taking the process of a raw like flat file and enriching it, and then to have that sentiment analysis, even bringing that into database tables with SSIS, and ultimately you could then use that for to visualize. And so just some of these comments that have sentiment analysis, you can.
So this is Power BI.
Yeah, so this is in Microsoft Power BI, and just for some of these sources here, you can see that the confidence was brought in from that sentiment analysis. Blue is more positive, and red is negative. There were negative comment flags in the text itself, and so you could analyze sentiment over time, and just how you're doing. You can hone in on just negative responses here, or just positive ones, and any other kind of slice that might apply to the data. And it makes it really easy to kind of search this raw data, because then you can search for specific things. If they're having problems with rats in their storage, then at least it's all here, and you can actually look at the specific details of those comments and with confidence. So so the data really enhances this ability to bring in a lot of that raw data and add and enrich it and enhance it to be able to visualize later on.
Okay, I think that kind of wraps up the demo section. We were just gonna, I think there was just a quick slide just as a recap. This is how we view the Azure, platform. I'm interested if anybody has any insight or questions. We'd love to open that up to that now.
Yeah, so we do have a little chat panel, so everyone, if you have any questions for Nate, go ahead and type them in. I have a few for you guys that were asked throughout the webinar. Here's one. Alvaro asks, is Data Lake equivalent to an ODS implementation?
That's a really good question. I think, some of us who've gone through, so ODS stands for Operational Data Store for everybody else on the call. I feel like the answer is yes, that it's the modern equivalent of what an ODS can be. A lot of us, when we were building our data warehouses in the past, have built ODSs to the side, or have built, these pre-staging environments where we were offloading the data. We feel like Data Lake has achieved that same kind of purpose, but is also expanding the use case. For instance, an ODS was never meant for data science supporting. An ODS has been good for supporting business apps, but I think a Data Lake and the advent of being able to support unstructured data, specifically the JSON type data of the world, has expanded what an ODS can do. So from our perspective, it's exactly that. It's kind of the modern ODS or pre-staging environment.
Okay, here's another question. Azure is nice. However, once you upload your data to Azure, you give the ownership to Microsoft in this case. Any comments on this?
Yeah, I mean, you're definitely giving up ownership, and there's egress costs if you ever want to get it back out. No doubt about it. The benefit, though, is scalability. For us, the history of our company was we were SQL Server guys, 10 years ago, and moving up to the Azure environment has been a breath of fresh air coming from just straight SQL Server. We're showing things here, specifically with the Data Lake or real-time data, that to build and maintain that infrastructure yourself is just not available to the mid-sized company. And so the benefit of having a platform as a service that Azure is, we're able to do things that far exceed what we were able to do when we were just on premise. I have a theory. I've never been able to prove that data warehousing specifically has more technical debt than any other kind of development. And by not having all of the infrastructure to optimize and maintain, just by being able to use those things as a service, you can focus on just maintaining the environment, or sorry, the solution that you're building. And so, yeah, there's definite trade-offs, but the benefits for us have far exceeded any kind of trade-off.
Gotcha. Paul has asked, Are there capabilities to show data lineage through the data lake?
No, the data lineage is something that, and Nate, tell me if I'm saying this wrong, is something that's not necessarily there, but through Azure Data Factory, you're really meant to control that lineage, or SSIS, you can control that lineage. You are executing one job at a time in Azure Data Lake, but there's not really a good GUI for data lineage. Having said that, we didn't talk about the data catalog at all. This isn't lineage, but it's a really great resource that if you are in Azure, we would recommend taking a look at. A great way to build the data dictionary. So when I'm looking at a value, whether it's in the data lake or the data warehouse, what does that value mean? What's the logic that the data warehouse team has applied to that specific metric? The data catalog's a really great lightweight way to deliver that data dictionary.
Okay. Here's another question. William says, besides USQL, how do you query and get data out of an ADLA database? Is it recommended to put data into an ADLA database?
Go ahead, Nate.
Yeah, in my experience with just trying to connect to those ADLA databases, I was hoping maybe a Power BI could connect straight to it, just like it would like an Azure SQL database. But from what I found, using those databases, they had to be output to another text file in order to be able to be used elsewhere. So even if it was a simple select star from whatever table in those ADLA databases, then that was the format that was the avenue I had to go through in order to get the data to be usable elsewhere. And so I'm sure on the horizon that Azure Data Lake Analytics, the databases will probably be able to connect to more and more things and be more direct. But as of right now, it still kind of has extra steps in order to get it out.
Yeah, and the manipulating the data is really meant to be in SQL. We mentioned that before. It feels like it's a combination of C# and SQL. And so it's a little bit more technical than your normal SQL developer is used to, but it's not overly so. They've done a good job of keeping it readable. The data science languages are available, so Python and R. That's not necessarily the way you would transform the data or enrich it, but you can hit the data lake with those as well.
Yeah, I think it has a good use case for, especially when it gets to just large amounts of data that might be easier to use SQL because it still is SQL-like, and so just to get the performance and resources from the data like analytics, it might make sense to be able to actually put things in that ADLA tables and just to be able to do some of those transformations early on.
You have to get used to applying that schema when you write your query, though. It's different for most people. Yeah.
Alrighty. Here's a question from Phil. You indicated you were initially a data lake skeptic. Why were you, and why aren't you now?
Yeah, I mean, the reason I was a data lake skeptic is because, and I showed that hype cycle, really what you were hearing at the top of that hype cycle was that the data lake was killing the data warehouse. You had companies completely abandoning data warehousing and starting new projects with this idea that the data lake was going to be this one version of the truth for their company. And we saw as markets go, right, we saw a lot of people try things and fail with them, only to come back to we need a data warehouse. And so the data lake, in our opinion, and this is where the debate starts, is it didn't replace the data warehouse, and it's not looking like it's going to. But what it's going to do is it's going to easily support each other, where the data lake and the data warehouse support different parts of the business and different use cases of the business. Just kind of recapping on something I said earlier, the data lake will support a fewer number of highly technical users versus the data warehouse, that its goal is to is to support a large amount of non-technical users. And I think that's been the biggest key, is realizing that the two of those combined are really a whole solution.
Okay. Question from Rob. How does processing flat files compare to relation queries?
So with those relation queries, and I'm guessing we're talking about either coming from different flat files or even from those ADLA tables that have that you'd actually use joins and things like that, and that's all possible in USQL for our use case. In the example, there wasn't any of those relation queries, but it's all possible in USQL and using those ADLA tables as like a landing ground to be able to perform some of those. And so the functionality is all there to do that as well.
Okay. Mike's asks, do you guys have a best practice for uploading data from data sources to ADLS?
Just like anything else in the cloud, there's a handful of ways to do it. The place to start is the Azure Data Factory, which has great connectors to insert the data into Azure Data Lake. I can't remember what they just renamed the Azure Data Gateway to. They just renamed the gateway, but that's also a big part of it, is that it's got a security element to be able to pass data securely up to the cloud. There are some, I can't remember the bulk copy. There's one specific that it looked like people had success with, but we didn't implement it. We just used Azure Data Factory.
Okay. I'm trying to take a few more questions here. We have a lot of questions that just came in. How long would the process of transitioning from an existing model to a data lake take?
Yeah, that's a really tough one, because we don't know what the existing model would look like. Let's just assume that you had, I'm going to take this as you tried to create a data lake, but maybe got a little bit backwards on the organization. What's great is it's very easy, and the storage is very cheap, that it honestly wouldn't be too hard for you to create an entirely new data lake environment and to create the folder structure that is more appropriate for your organization, and just copying those files from one data lake to the other. I don't know, do you have any thoughts other than that? It really exists. If you need a complete rewrite, that's the way I would do it. It's not too much of a burden to create a new data lake and a new file structure from scratch.
Okay, and I'm going to take one last question before we wrap things up. Is there any way to store and query binary data in Data Lake? All of your examples are text or JSON files.
Yeah, I don't know. That's one we haven't kicked the tires on. So I would be interested to know if anybody else has hit anything that's binary.
All right, sounds good. Well, I am going to wrap things up. Thank you so much, Nate and Nate, for joining us and contributing to our weekly webinars. Again, I think this is a great opportunity for you guys to add some variety to our Tuesday webinars, and it's been great having you. I have a couple people ask, as we do every week, about a recording of the webinar. So I do want to let you guys know that we record all of our sessions, and we will be sending all of you a follow-up email that includes a link to that recording. Additionally, you can find the recording on our website at pragmaticworks.com. And that usually will be posted a few hours after this webinar. So thanks again, everyone, for your time, and we look forward to seeing you all next Tuesday for another free training session. And thanks again, Nate and Nate from Zerva.
Thank you, Erica. Have a great day.
All right. Take care, guys.